Hello, my name is Sude Nur Keleş. I am a physics student at Bilkent University and this is my Physics 102 final lab project. The main goal of my project was to measure the magnetic constant by using Ampere's law. In order to calculate the magnetic constant, I prepared a circuit composed of a power supply, two solenoids with 200 turns and 400 turns, and a meter, crocodile cables, and a resistor with a 100 ohm resistance. In the first part of the experiment, I used the solenoid with 200 turns and increased the voltage in the circuit from 3 volts to 17 volts. Then I repeated the experiment by using the solenoid with 400 turns and measured the magnetic field inside the solenoids by using a Gauss meter. Ampere's law suggests that magnetic field and current is directly proportional. Hence, after obtaining the results, I prepared a table to show the relationship between current and magnetic field. And by using these values, I plotted two graphs with respect to magnetic field and current for both solenoids. Ampere's law for solenoids suggests that magnetic field is proportional to magnetic constant, turns per unit length, and current. Using this equation, magnetic constant can be found as magnetic field divided by turns per unit length times current. The slope of the plotted graphs give the magnetic field divided by current. By dividing this value to turns per unit length, we obtain the measured value of magnetic constant. For the solenoid with 200 turns, slope is calculated as 1.5 times 10 to minus 3 teslas per ampere, and magnetic constant was calculated as 3 times 10 to minus 7 tesla meter per ampere. For the solenoid with 400 turns, slope is calculated as 2 times 10 to minus 3 tesla per ampere, and magnetic constant was calculated as 2 times 10 to minus 7 tesla meter per ampere. As we move away from the center of the solenoid, the magnetic field decreases rapidly. In the experiment, the Gauss meter was taped to the solenoid, and hence I was not able to measure the highest value of the magnetic field as it was not taped to the center of the solenoid. This caused error to be so high. Also, the table I used for my experiment was not stable and the resistance of the circuit elements was ignored. Due to these reasons, I measured my error so high. In short, I was able to calculate the magnetic constant by using different solenoids with different turns. But due to imperfect lab conditions, my percentage error was high. Thank you for your attention.